I literally am like this. I was at
star power, I guess St. Peter. St. Peter. No, like the rock. I have to do about this bracket. I have to do this bracket after the 1 and 2. Let's see, I didn't say it.
Now I'm going to have
It's a little light. It's only a few
and then
I don't know, there's TCU. Was giving them yeah, because TCU is the shame. Oh my god. And I think TCU wasn't the secret. Ohio State off the second period, but what's the song for these sports like? Big sucks too. Wow, one of those teams.
okay, for letter B, I'm going to rewrite that. So, oh, I'm sorry, I can't do that. I'm looking at this one, I'm actually going to have to do new substitution. So I'm going to say use minus 5. I'm going to take the derivative of 2, 3x squared with x, and then I'm going to look at what I have. So, in my highlighters, I'm going to have my u. I have there, and then I have x squared dx, so there's x squared dx. So I'm going to have to make 1/3 du of the x squared dx. So I'm going to rewrite
Joseph, come to the office. Joseph,
x squared dx is 1/3 du. So I'm leaving up over it is and then we have 1/3 du. I'm going to multiply 4 and 1/3 together, so we have 4/3 du 1/2. Now I'm going to take the left-hand derivative. So when I do that, I'm going to add 1 to the 5 halves. Here's the 4 derivative started off with, and now I'm going to multiply by the derivative, and then like the plus c. So I'm going to multiply and have 8 times rewriting with the x, I'm going to I'm going to rewrite that again, and I'm going to have x times 25 minus 9x squared. That's raising negative 1/2 power. I realize that I'm going to have to do substitution, so I'm going to say that 25 minus 9x squared. The derivative of that u is going to be negative 18x. When I highlight what I have my u, which is this. And then I have x dx, here's my x, here's my dx, x. So I'm going to make negative 118 u equal to my x dx. So now I'm going to rewrite that in terms of u. So the x dx will be the negative 118 u, and then I'm going to have u to the negative 1 half power. I'm going to add 1 to that negative 1 half, so we cos 1 half, multiplied by the reciprocal, so that would be 2 over 1, and then I'm going to have times negative 118 plus c, and then multiply the 2 times negative 118, I'm going to get negative 19, right, u to the 1 half plus c. Substituting in the u, I'm going to say f of x is equal to negative 1 9, and then this will be 25 minus 9x squared, and 1 half plus c. F, I am going to, I do not have to do the substitution, I'm going to think of this as x to the third times x to the 1/4. X, I am going to add the exponent, so I am going to have x to the 13 on now that's going to add 3 plus 1/4. Now I'm going to add 1 to the inside derivative, so that was 17 multiplied by the reciprocal, 4/17, and then there's that plus c. So when I substitute, I don't have to substitute that. I'm going to say f of x equals 4/17 times x is 7/4 plus c. And moving on to the next one. Okay, on this one, I'm going to read the directions. Directions tell you that the particular solution for differential equation, and it's f of prime x, I mean the derivative of the function is the same as x squared of x. It goes past the point that I gave it 15, set up an integral with proper notation before you begin. So what it's telling you is it's telling you to take, set up the integral, proper notation, which means you have integral notation and you have a dx at the end. And then what I'm going to do is I am going to rewrite this. So I'm going to rewrite it as negative 3x to negative 1 half dx. And now I'm going to take the antiderivative because this point is my f of x point, if that makes sense. So I'm going to take the antiderivative, I'm going to add 1 to negative 1 half, which will be positive 1 half. There's a negative 3, multiplied by the reciprocal, which is 2 over 1, and then I'm going to add c. So if I rewrite this, this will be negative 6x to 1 half plus c is equal to f of x. That's my original function. My original function goes through this point. This is my x and this is my y. Remember, this is my x and this is my f of x, because f of x is the same thing as y. I'm going to substitute it in 9 for x, and I'm going to substitute in the negative 15 for my y, or my f of x. So I'm going to negative 15 is equal to negative 6. The square root of 9 is 9 raised to 1 half power is equal to 3. And that negative 15 is equal to negative 18 plus c. Solve to proceed at 18 equals 5. And negative 3 is equal to c. I'm going to finalize it by writing the equation. So f of x is going to equal at negative 6x to 1 half, and in place of that c, I'm going to write 3. And that is my final answer. Moving on to the next one. I want to find the limit of x net as n approaches 3 given all that. So I am going to, I'm taking the limits as n approaches infinity of that 81 n to the 4th times n squared n plus 1 squared over 6. I'm going to simplify that before I start taking the, so I'm going to distribute this. Well, I can't simplify that yet. I'm going to make this n squared and this is 1. These both have a factor of 3, so this will be 27 and this will be 2. So now I'm going to take the limits as n approaches infinity, and 27 over n squared times, and then this will be n squared plus 2n plus 1 all over 2. Now I'm going to multiply that, so I'm going to distribute this. So we have 27 n squared over 2n squared plus 54n over 2n squared plus 27 over 2n squared. Here, the n squared simplify. And I'm going to have 27 over 2. Here, 1 n will simplify, so I'll have 54 over 2n. Here, nothing will simplify, so 27 over 2n squared. Now, as I take the limit as n approaches infinity, there's no place to put infinity into the first fraction, so that's going to be 27 times. This one, when I put infinity into this one, I'm dividing constant by a larger and larger number, that's going to approach 0. Divide 27 by a larger and larger number, that's going to approach 0. So my limit is going to be that 27 over 2, or I guess I could write it as 13.5. Alright, moving on to the next one. The next one says use properties of sigma notation in the summation formulas to evaluate the given sum. So what that wants me to do is it wants me to break this up term by term by term. So I'm going to write the summation symbol for every single term. 3k squared plus k minus I like to take my constants out front. So this is 3k equals 1, 7 of k squared, plus there is no constant here, so this will stay the same. And then this 5 is technically going to bring out here, and then this will be plus 1. So when I do this, I'm going to have this 3, and then anything squared is going to be this formula here. So it'll be 3 times n plus 1 times 2n plus 1 all over 6. And then k is going to be k, this guy right there, 5k plus, this will be n times n plus 1 over 2, and then minus, and then the constants, cn, well I put a 1 there, so this one is 5. So when I simplify, and I'm going to substitute, so here my n in this case is 7, so n is equal to 7. So we put 7 in and simplify. How does you do that all at once? I think I will. 3, and 7. 7 plus 1 is 8. 14, 15 over 6 plus 7 times 8 over 2 minus 5. So I'm kind of simplifying before I multiply. 3 goes into 3 once. This is 4. And when I multiply 7 times 4 times 15, it's 420. And these will simplify. So I'm going to have plus 8 times 5 and 35. Let's see. My n there. And 35. And then I'm going to have 400. And moving on to the next one. So this one says find formula, the sum of n terms, use the formula as n approaches infinity. So they give me that formula right there. So I'm taking the limits as n approaches infinity of I is equal to 1 to n. And then I'm going to multiply this to make 4i over n squared. I just multiply this two terms together. Now what I'm going to do is anything that does not have an I, I'm going to bring out in front of the sigma. So I'm going to have 4 over n squared, and then sigma I is equal to 1 to n, and then I. And now what I'm going to do is I'm going to use that pattern for I, which is this guy right here. So I am going to take the limits as n approaches infinity. 4 over n squared, that's on here. And then in place of this, I'm writing the formula, which is n times m that I'm taking the limits as n approaches infinity, distributing the 2, this will be 2n over n plus 2 over n. Here the n's will simplify, so I'm going to take the limits as n approaches infinity of 2 plus 2 over n. Now I'm ready to take the limits. I have simplified. There's no place for me to put n here, so that's going to stay 2. And then as n gets multiplied in order to divide by 11, our number will approach 0. So plus 0, and the leave has to just straight. Okay, number 6 is the Riemann sum. So this is where you're going to write like the area of rectangles as it gets smaller and smaller. I'm going to take my integral. So I am going to, so the width or the base of each rectangle is going to be that 3 minus 0 technically over n, so 3 over n, that's going to be the width. The height of each rectangle is going to be what happens when I put that 3 over n into the formula. That would be the height. And I'm going to do a summation so I can keep on putting more and more, like go down those intervals. So this will be 3I over n squared plus 9. So that's the height of my rectangle. And I have to multiply by the width, which is at 3 over n. So when I'm taking the limits as n approaches infinity, because I want more rectangles in the office. So I'm going to say limit as n approaches infinity. I am going to square this. So I'm running this 3n here. And I'm going to square the 3, which is 9, square the I, which is I squared, square the n, which is n squared, plus 9. Now I'm going to go ahead and distribute this 3n. So I'm going to take the limit as n approaches infinity. And when I do that, I'm going to have 27I squared over n to the third plus 27 over n. Now I'm ready to separate term by term for the limits. So this is where I am going to take the signal for both of them. Anything that does not have an I, I'm going to pull out in front. So the limit as n approaches infinity, the big old bracket there, 27n cubed I'm pulling out in front. And we have I is equal to 1 n of I squared plus 27 over n. I'm going to do 1, and I'm just going to throw 1 there to hold that space. So still taking the limits as n approaches infinity. There's that 27 over n cubed. I squared, the pattern for I squared, for this guy here, is going to be that n times n plus 1 times 2n plus 1 all over 6. And then here I have the plus 27n, and then the pattern for this 1 is going to be n times 1, so that would be 10. When I multiply, this one I can just multiply. No, I like to do that. Now I'm taking the limit as n approaches infinity. That's 27 and 3. And multiply it by this. And so that's 1, 2, and 1, 6. And then 2 is 27. I'm going to simplify the n cubed element n squared. That simplifies to n. 6 will go on that 2 times. It will go to 27 9 times. When I multiply these two, when I FOIL them, I get 2n squared plus 3n plus 1. So what I'm going to do is I'm going to distribute the 9 and the n squared. So I am going to have 18n squared over 2n squared plus 27n over 2n squared plus 9 over 2n squared plus 27. simplify. When I simplify, this becomes 9. Plus, here I'm going to have to n1 and simplify up 27 over 2n plus 9 over 2n squared is 27. As n gets larger and larger and larger, this will approach 0 and this will approach 0. So I'm left with 9 plus 27 because there's no place for me to substitute n in there. And I end up with 36 as my final answer. So that would be the area underneath the curve x squared plus 9 on the interval from 0 to 3. And the next one says you use Lehman sum to approximate an upper and lower sum using 3 subintervals over an interval of 0 to 6. So I'm going to take 6 minus 0 divided by the number of intervals I want, which in this case is going to not be n because they tell me I want any intervals. So 6 divided by 3, which means the base of each interval is going to be 2. So then when I write my summation formula, just like I did before, I equals to 1, I'm going up to 3 because I want 3 subintervals. So my n is equal to 3. The base of each one is 2. And then I'm going to have one that's going to be 7 minus the square root of I, putting I into x, 2i. And when I put that in my calculator, and I'm just putting that in my calculator, I'm going to get 30.2726. Then what? The other way I'm going to do it is I'm going to do everything exactly the same. 2 and then 7 minus the square root of 2 and then I minus 1. This will be taken to the left side instead of the right side. And when I put this in my calculator, I am going to end up with 35.1716. And the lower one is the lower limit. And the higher one is the upper limit. And that's all I have to do. When you have this too, you're going to have to make sure that you put that in there with the I. And then when you can use this one, you can write it like this, or you can have 2 times 7 minus the square root of 2i minus 2. Those are the same. However you want to write it. Okay, moving on to the next one. It says sketch the region whose area is given by the definite interval. So if you don't have a picture, you're not getting full credit. Then use geometric formulas to evaluate the interval. So here I'm going from -2 to 5. I'm going to graph that on my calculator. And when I graph it, I see that I have a line that goes something like this. And what I care about this line is I care about this point here, which is -2, and then I have to find the y value. To find the y value, we take 1 minus 2 times -2. So that's going to be 1 plus 4, so that's going to be 5. So this is going to be 2, 5. Then I'm going to find this one here, and when I find that point there, I'm going to substitute 5. So 1 minus 2 times 5, this is 1 minus 10, and then -9. So this order here is 5 and -9. But I have to find a place where I form two triangles. So I'm going to have this triangle, and I'm going to have this triangle. I need to know what this point is called. That's where it crosses the x-axis. Where my y is equal to 0. So I'm going to say 1 is equal to 2x, and x is equal to 1/2. So this order there is 1/2 of 0. So I'm going to use that because I have 2 triangles. This first triangle is going to, the area down is going to be 1/2. The base, well, between -2 to a positive 1/2 is going to be 2.5. So I can write 2.5 or 5 halves, however you want to write it. I know 2.5. And then the height of this triangle is going to be 5. And when I multiply all that, I get 25 fourths, or you can have 6.25. Either one is acceptable. Now to do the area of this triangle right here, I'm going to go from 1/2 to 5. So the 1/2, the base, which would be 4.5, and that's the distance between 1/2 and 5, times the height, which is 9. And when I do that, I get 81/4. Since it's below the x-axis, I'm going to make it negative. So when I do that, and then that is the decimals, negative 20.25. And when I add that up to negative 14, and that is my final answer. Okay, the next one is an absolute value. So this one tells me that I have to do it graphically. I'm not giving you a choice. So the first thing I need to do is I need to find out where the vertex is. So I'm going to take that 4x minus 7 and set it equal to 0. So I'm going to have 4x equals 7x equals 7/4. So here I'm going to have 0, 7/4. Then I'm going to 0 here somewhere. So here's 0. And when I substitute in 0, I'm going to have 4 times 0 minus 7. So I'm going to have negative 7. So 7. So this goes like that. And then I'm going to have to sort it here, which is 0, 7. And then this one over here, square root means nothing. Then this one, to find this, 6 is where the interval ends, so I'm going to find this point here, so I'm going to take 4 times 6 minus 7, so it's 24, 24 minus 7, which is 17. This point here is 6, 17. So now I have two triangles. They're both positive, so I'm going to add the two together. So this triangle, I'm going to do 1/2. So 1/2 the base, which is that 7/4, times the height, which we said was 7. And when I do that, it's 49/8. Or you can have 6.125. And to do the area of this triangle, I'm going to take 6 minus 7/4. 6 minus 7/4, which is 17/4, times the height, which is 17. And when I multiply that, I get 289 over 8, which ends up being 36.125. And when I add those together, I get 42.25. And that's the area underneath that curve. Next one, use geometric methods to evaluate each. So A wants you to find when x of x is equal to 3 over the interval from 0 to 5. So here's 0, here's 5. F of x is equal to 3 is a horizontal line. So I want this on but I just care from 0 to 5, so I care about this rectangle here. So that's going to be the base, which is 5, and the height, which is 3. So my area underneath the curve is going to be 15. The next one was 4 minus the absolute value of x. So when I sketch that, I get this is negative 4, this is positive 4, this is the place where it's 0, and this point here ends up being 4. So when I go to do this, I'm going to do this triangle first. So that will be 1/2. Actually, I can just do one big triangle. I think the base is 8 and the height is 4. I'm going to get 16. If I were to divide it into two triangles, it's still going to be the same answer. Moving on to the next one, it says use the information to evaluate the definite interval. So it's telling me that g of x is even and f of x is, oh no, I got that wrong. G of x is odd and f of x is even. So when I go to do 0 to 4 of f of x, so they're telling you that from -4 to 4 is 7. And f of x is an even function, which means that means that this is equal to 2 of one of those. So this will just be 7 halves. Because on an even function, like if I just grab off negative 4 to 4, I don't know what the function is, I'm just guessing. But here, if you whatever this interval is, this is going to be the same. So that together they add up to 7, then only one of them is going to be half of that. That's how I got the 7 halves. All right, doing B 3 times G of X. 9, so the interval 9 to 4 matches. So I'm going to separate this as 3, 4 to 9, G of X plus 4 to 9 of plus 5. So this is 3. This 4 to 9, G of X is negative 2. And then this, remember, makes a rectangle. This is a rectangle. And I'm going from 4 to 9. So my base is 5. My height is 5. So 5 times 5. So I'm going to end up with negative 6 plus 25. And my final answer is going to be 19. This one, I'm going from 4 to negative 4. So I've taken this interval and I've switched it by the opposite direction. That means I have to put a negative sign there. So the opposite. So I'm just going to take the opposite of negative 4 to 4, which is 7. So my final answer is going to be negative 7. And the last one, I'm going from negative 1 to 1. So I'm going from negative 1 to 1. G of X is an odd function, which means it looks the same as this is an odd function, just X, which means that this triangle will be the same as this triangle. So if I'm going from negative 1 to 1, then that's just going to be 0. And that works because it is an odd function. And you need to remember those properties. Moving on to the next one, it says find the definite interval. Now I have numbers, so I'm going to take the antiderivative first. So this will be 2x plus add 1 x squared divided by 2. And then I don't have to write plus c because I'm going from 0 to 2. Now this is where I substitute in 2. So 2 times 2 plus 2 squared over 2. Minus substituting 0 now, 2 times 0 plus 0 squared over 2. And I end up with 6 minus 0, which is 6. The next one, I'm going to distribute that x. I'm going to think of this as 0 to 1, x to 1 half, and 1 minus x to the x. Distributing that, and x to 1 half minus add exponents of 3 halves. Now I'm going to take the antiderivative, so I'm going to add 1, so this is x to 3 halves, multiplied by the reciprocal 2/3, minus add 1, so this will be 5 halves, multiplied by the reciprocal 2/5, and I'm going from 0 to 1. So I'm going to take 2/3, I'm going to take 2/3 times 1 to the 3 halves power, minus 2/5 times 1 to the 5 halves power. So that's going to be 2/3 minus 2/5. And when I do that, I get 4/15. I'm going to do the other half, and I'm going to put in 0. So minus 2/3 times 0 to 3 halves, minus 2/5 times 0 to 5. And that ends up being 0 minus 0, 0. So my final answer is 4/15. Or you can have decimal 2.6. Okay, the next one, I am going to take the antiderivative, so this is t to the third divided by 3 plus 2t, going from negative 1 to 1. So this will be 1 to the third of 3 plus 2 times 1 minus, and then negative 1 to the third of 3. when I do this, I get 7/3 minus -7/3 plus +14/3, and that's my final. If you recognize that in the function, I've taken the antiderivative of -x² divided by 3 multiplied by 1/3 plus x² divided by 2 plus 2x going to -3. Substituting in 3 first, I am going to have -3/3 over 3 plus 3/3 over 2 plus 2 times 3 minus putting in the -2, so this is -2/3 plus -2 squared over 2 plus 2 times 2. So when I substitute in 3, and I hope that you're using such that to make this go a little faster, I get 3/2 minus 2/3. My final answer is 5/6 or 0.83. Okay, the next one, before I take the antiderivative, I'm going to distribute that x first. So -1 to 2, x to the third, minus 4x dx. Add 1 to this, so this will be x to the fourth over 4 minus 4x squared over 2. And 1 -1 to 2. I'm probably just going to do x to the fourth over 4 minus 2x squared before I start substituting in. And when I substitute in, I am going to have 2 first, so 2 to the fourth over 4 minus 2 times 2 squared minus and -1 to the fourth over 4 minus 2 times 1 squared. I'm going to do that and substitute 2, that makes 4 minus and substitute in the -1, and it leaves them in force. So when I subtract that, I get -9 fourths or -2.25. Moving on to the next one. It's an absolute value. I am probably going to, I'm probably going to make a picture together all the pictures. So I'm going to find the vertex first. So to find the vertex, I'm going to take 2x minus 1 second equals 0, 2x equals 1, x equals 1/2. So when I draw my picture, I'm -2, and it doesn't have to be exact, you just have to have a visual representation of what you're doing. This point here is going to be 1/2, 0, and then I'm going to have 5. I have to find out how tall this triangle is. So to find out how tall this triangle is, I put -2 in. So 2 times -2 minus 1. So that's -4 minus 1, so that would be -5. So that would be 5. So this word here is going to be -2 to 5. This over here, when I do 5, I'm going to have 2 times 5 minus 1. So that's going to be 10 minus 1, which is 9. And the absolute value of 9 is 9. So this one is going to be 9. So I have 2 triangles. This triangle here. So I'm going to have 1/2 the base, which is 2.5, times the height, which is 5, plus we're going to do this triangle here, which its base is going to be 1/2 the base, which is 4.5, times the height, which is 9. And then I'm going to multiply those. Hold on. So when I multiply, I got 6.25 and 20.25. And when I add those together, I'm going to get 26.5. And that's going to be my final. That's probably the best way to do it. So I'm just do that. Okay, the next one, number 12. Hold on for a second. Okay, I just I did skip that, so I came back to that, so sorry about that. I didn't calculate too much. All right, I'm going to rewrite this 3 to 6. I'm going to rewrite this as 1/3 x times x squared minus 8 to the negative 1/2 power dx. So then I have something raised to power, so I'm going to have to do that u substitution. So I'm going to say u is equal to x squared minus 8. I'm going to say du is equal to 2x dx. When I go substituting in here, or looking for what I can't substitute in, right, writing everything in terms of u, this takes care of that. X dx, x dx, I can take care of that. I just have to get this 2 over to the other side. So I'm going to say 1/2 u is equal to x dx. Now I'm going to write this all in terms of x, in terms of u. So I'm going to have 1/3 u to the negative 1/2 power, and then 1/2 du. And then I'm going from 3, but remember that x is equal to 3, to 6, x is equal to 6. And I have to write x is equal to because I put everything in terms of u, and that 3 and 6 is based on being in x. So now when I simplify this, so I'll rewrite this a little bit, I'm going to x is equal to 3. I multiply 1/3 times 1/2 and 1/6, u to the negative 1/2 u. Now I'm ready to take the antiderivative. So when I take the antiderivative, I'm going to add 1, so that'll be equal to 1/2. Here's the 1/6 that I started off with. 1/6, and then I'm going to multiply by the reciprocal of the 1/2, which is 2 over 1. I don't have to write the plus c because I have these numbers, so I have that integral. So again, I'm going to write x is equal to 6. When I simplify that, because I can multiply the 2 with the 1/6, I'm going to get 1/3 u to the 1/2, and then x is equal to 3, x is equal to 6. Now, choice how I can do this. I'm sticking with the u, which is fine. If I stick with the u, I have to find the lower limit. So to find the lower limit, that's when x is equal to 3. But remember, u is equal to x squared minus 8. So my lower limit would be u is equal to x squared, so 3 squared minus 8. So that's 9 minus 8, which is 1. My upper limit, u is equal to, my upper limit is 6 squared, so 6 squared minus 8, which is 36 minus 8, 28. So if I do this, I'm going to do 1/3 u to the 1/2, and then my lower limit is 1, my upper limit is 28. So I am going to have 1/3 the square root of 28, this minus 1/3 times the square root of 1. So I'm going to have the square root of 28 over 3 minus 1/3. Well, that's just Jeffy, so I made it a decimal, and that was 1.439. If I chose not to leave it as u and decided to leave it as the fact in terms of x, then this is 1/3. U is equal to x squared minus 8. So I'll take this one from 3 to 6. So now I'm going to take 1/3, so it's 6 squared minus 8 raised to 1/2. Minus substituting in the 3, so 1/3, 3 squared minus 8, so 3 squared. So this ends up being the square root of 28 over 3 minus 1/3, and I'm going to end up with 1.43. So either way, you do it, you get the same. Sorry, I skipped that one. Moving on to 12, find the average value. As soon as it says average, remember when you find the average, you take the total and you divide it by the number of numbers you have. So in this case, it wants the average value over a given interval. And the interval is from negative 3 to 6, so I'm going to take 1 over 6 minus negative 3. So I have 1 this, when it says average, the only thing you're adding is you're adding this 1 line after that. That's it. That's all you're doing. So when I do this, so it's anti-derivative, so this is x to the fifth, there's 3 divided by 5, and I'm going from -3 to 6. But remember, when I get my answer, I'm going to multiply by 1/9. So when I do this, I get, I'm going to substitute in 6 first. So, 3 times 6 to the fifth over 5 minus 3 times negative 3 to the fifth over 5. So that ends up being very big numbers. So this I have 2, 3, 8 over 5 minus negative 729 over 5. And then I just said 1/9, and I got, I keep it this way, 24057 over 5 multiplied by 1/9, that ends up being 267 over 5. Or if you did the decimal, it's 534. Whatever, The next one, determine the area of the region under the graph of 1 minus x to the fourth above the x-axis. All that means, you're going to go from -1 to 1, go above the x-axis. How do I know that's above the x-axis? Because I want this 1 minus x to the fourth to be greater than or equal to 0. So 1 to be greater than or equal to x to the fourth, take the fourth root, so when I end up with plus or minus 1, x, that's how I got that -1 to 1. And then I'm doing 1 minus x to the fourth, x. So now when I take the antiderivative, I'm going to x minus x to the fifth over 5, and -1 to 1. So when I do this, I get 1 minus 1 to the fifth over 5, -1 minus -1 to the fifth over 5. So I get 4/5 minus -4/5, and it's going to be 8/5 or 1/6. If you would have graphed it, which I'm assuming most of you would have graphed it instead of doing this, you would have had something like this. This is -1 to 1. At this point, I can tell some of the functions. So once I hit this before this, and this is also going to support this. But it's just easier to do one. The next one, consider the f of x is equal to x1 to x squared to the third x squared t, and I want to find this at 2. So I want to find this at 2, so I am going to take this x squared, and I'm going to put it in here, so f of 2. So I'm going to rewrite this as x squared is the third power plus the square root of x squared. So now I'm going to rewrite this. Remember that one, if you see how the capital F is still capital F, so all they have to do is substitute that x squared and replace the c with c, and then multiply by the derivative of the x. In this one, it says write the accumulation function in terms of x, given that f of x is equal to that. The first thing I did is I rewrote this, and I thought of it as 16 cubed over t minus 9t over t. I thought of it dt. What I can do then is I can either substitute in the x now, or I can take the antiderivative. So I'm going to take the antiderivative first. So when I take the antiderivative, I'm going to have the 6 raised 1 power divided by 3 minus 9t. And 1 from negative 5 is x. So now I'm going to substitute the x in. So I'm going to have 6x to the third over 3 minus 9x minus, and now I'm going to substitute the 5. So 6 times 5 to the third over 3 minus 9 times negative 5. When I do that, this is going to say, well, actually, it's going to be 2x to the third minus 9x. And then this whole thing ends up being negative 205. So we're going to do minus minus to become positive 205. And that is going to equal the accumulation function. So it's capital. And that's all I have to set. Moving on to the next one. So this one I want you to find the following. So I can go this one from negative 6 to 10. So from negative 6 to 10, I think from negative 6 to negative 1 is that triangle. Plus from negative 1 to 0 is that half circle. And then from 0 to 10 is that triangle that looks like this. Y'all agree? So if I'm trying to find this one, this would be 1 half. The base from negative 6 to negative 1 is 5. The height of that triangle is 2. And then plus, this is going to be half of the circle. The radius of that circle is 3. So 1 half pi 3 squared. And then from 0 to 10, so it's going to be a triangle 1 half. The base is going to be, oh, no, this is 5. This is 5. The base is going to be 5, and then the height of that triangle is going to be 4. But I'm going to also remember that this is below the x-axis, so this whole thing is going to go down. Boy, I'm running out of room fast. So then when I write this, I get 5 plus 9 halves pi minus 10. I at least have to write negative 5 plus 9 halves pi. I can leave it like that, or I can change it to the decimal 9.1375. Okay, number 10 from negative 1 to 10. So if I'm going from negative 1 to 10, do we agree that I'm just doing negative 1 to 10, negative 1 to 10? I'm just doing these two right here. We agree? I hope we agree. So I'm just doing this part right here. So that'll end up being 9 halves pi minus 10, which is decimal 4.1377. If you want, you can still do the 1 half pi r squared plus 1 half base times the height. You have to remember that this should be going downwards, so that's just minus sign. Okay, number 5, or sorry, C, I'm going from 5 to negative 6. So I don't like the way that that's written, so I'm going to rewrite it as a negative 6 to 5, because I'm going to take the opposite and take it to the direction that I want it to go. So to do this, I'm going to just know that it's opposite of whatever I come up with. I'm going to go from negative 6 to negative 1 first, which is going to be that 5. So we agree that that's 5. And then I'm going from negative 1 to 5, which is that 6. So I'm going to have a triangle, and I'm going to have a half circle. So I'm going to use the negative sign out front. So this is 1 half the 5 times the 2 plus 1 half pi 3 squared. So this will end up being 2 plus 9 halves pi. But I'm going to get the opposite, so I'm going to end up with negative 5. 5 minus 9 has pi. And if I want a decimal, that is going to be negative 19.1372. For D, I'm going from 2 to 9. 2 to 9. Well, 2 is doing that quarter of a circle. So 2 to 5 is that quarter of a circle. And then 5 to 9 is going to do a triangle. So I'm going to do 1/4 of that pi r squared plus, and then from 5 until base, 1/2, the base is going to be 4, and then the height of that triangle is still going to be that 4. But since it's below the x-axis, I'm going to remember to make that negative. So I'm going to have 9/4 pi minus, I'm going to multiply that with 8. Whoa, and then I go up here and I say, oh look, there's an absolute value symbol, so guess what? This doesn't have a negative plus. And now I get 13.06. Okay, E, I'm going from -1 to 9. So I'm doing, and I have this 5, so I'm going to do 5 times the whole thing. I'm going to go from -1 to 5 plus 5 to 9. This is going to be the half circle. This is going to be the triangle just below. So there's that 5 out in front. So this is 1/2 pi r squared plus, this is going to be 1/2, my base is 4, my height is 4, but since there's no absolute value sign is below the axis, I'm going to put a negative sign there. So I'm going to have, this will be 9/2 pi minus 8, and then, whoops, we have 9 pi over 2 minus 8, distributing that 5, and end up with 45 halves pi minus 40. That's the decimal, that's going to be positive 30.15. And the very last one, I am going to go from -6 to, I'm going to go from -6 to 2 of f of x plus -6 to 2 of just 3. So I'm going to go from -6 to 2. I'm going from -6 to -1, which is going to be that triangle again. And then I'm going to go from -1 to 2, which is going to be a quarter of a circle. And then I'm going to do this guy here, which is going to end up being a rectangle. So, and that's going to be a rectangle that goes from -6 to 2 and has a base. So this is going to be 1/2 pi times 2 plus 1/4, this is quarter of a circle, pi r cubed plus, and then this is going to be -6 to 8, I'm sorry, from -6 to 8 times 3, so I'm going to have 5 plus 9 pi over 4 plus 1/4, so 29 plus 9 pi over 4, and then the decimal that's 36.0666. I hope that helps. I hope it's done in less than an hour, and I did, yay!